Exercise 7, Advanced Integration Techniques, T formulae. Question number 1. Evaluate the integral between pi upon 2 and 0 of 1 over 2 plus cos x dx. Right, I just pause the video and have a go at this one. Okay, now I'm not going to go through and derive all those formulae again. I'll just write them down because they're in the previous lesson if you want to look at that. So we can say that when t equals tan x over 2, we know that cos x is equal to 1 minus t squared over 1 plus t squared. And we know that dx is 2 over 1 plus t squared. The limits, okay, when x equals pi upon 2, this will be tan of pi upon 4, so t will be equal to 1 when x equals pi upon 2, and t will also equal 0 when x equals 0. So we have the integral as equal 1 and 0 of 1 over 2 plus 1 minus t squared over 1 plus t squared times 2 over 1 plus t squared dt equals, take the 2 at the front, that's 1 over, now these will cancel out. Before that happens, that goes up here, becomes 2 plus 2t squared plus 1 minus t squared dt. And of course that becomes naught of 1 over 3 plus t squared dt. And that's the inverse tan function, but that's root 3 squared, so that becomes 2 over root 3 tan to the minus 1 of 1 on root 3, or t on root 3 between 1 and 0, and that's 2 on root 3 tan to the minus 1 of 1 on root 3 minus 10 to the minus 1 of 0 is just 0, and that's going to become 2 on root 3 times pi on 6, which is pi over 3 root 3, or if you want to rationalize, pi times root 3 over 9, or pi root 3 on 9. Okay, question 2. Find the integral of 1 over sine x plus cos x dx. Now remember, in the actual example I used a minus sign, so the same sort of procedure to see if you can remember how to do it. Alright, now here's the solution. Again, writing out the formulae. We know that the sine of x is 2t over 1 plus t squared, and the cos of x is 1 minus t squared over 1 plus t squared, and we know that dx is equal to 2 over 1 plus t squared. So our integral becomes 1 over 2t over 1 plus t squared plus 1 minus t squared over 1 plus t squared times 2 over 1 plus t squared dt. Now all these will cancel out down the bottom, so you just get 2 over 2t plus 1 minus t squared. Now what I'm going to do, I'm going to change the signs there, because it's not nice having a minus on a t squared. I'll stick that minus sign up the top. Do that. And you're going to have here a t squared minus 2t minus 1. And then you can take the minus 2 out, what you could have done at the beginning, I guess. 1 over. Now this is t squared minus 2t plus 1. Now this will be a minus 2 here. dt. So that's going to be 1 over t minus 1 all squared minus root 2 all squared. And again, we'll do a little bit of a fiddle here. Minus 2, 1 over t minus 1 plus root 2, t minus 1 minus root 2. Using the difference of 2 squares. Well, what's these dt's? I think I left one off on the previous exercise. Sorry about that. Okay, now, this I'm going to write as minus 2. Now, right, this is, we'll do the, I'll do it this way. 1 over t minus 1 minus root 2. And then minus 1 over t minus, just by inspection really, isn't it? Rather than using the longer method with partial fractions. Now that goes up there, so this will legally be knocked out. So there's your plus root 2, and there's your plus root 2 again. And again it'll be over 2 root 2. So that's minus 1 on root 2. Now this will be the log of t minus 1 plus root 2. Oops, did it again. Sorry about that. That one minus that one, so it's over this one, using division. I think I was thinking ahead a little bit there, because I'm going to switch it now. Take that minus sign, turn it upside down, make it 1 on root 2. You leave it like that, you don't worry about the rationalising it. The log of, now you write t minus 1 plus root 2 over t minus 1 minus root 2. But don't worry, if you had that way, that's fine. Don't forget your constant. The end.